Very good morning. So we'll be discussing about the control chart for attributes, especially the control charts for defects, namely C control chart and U control chart. Already at the beginning when I was discussing about the control charts for attributes, I have given you the control limits. So we know that the control limits for C chart is upper control limit C bar plus 3 under root C bar, and lower control central line is C bar, and lower control limit is C bar minus 3 under root C bar. And for U chart, upper control limit for U chart is U bar plus 3 under root U bar by N. Central line is U bar. Lower control limit for U chart is U bar minus 3 under root U bar by N. Okay, at this juncture, I want to clarify two things. What is that? Any of the control charts, whether it is irrespective, whether it is control charts for variables or the attributes, one thing is common. Any control chart. What are those? Can you identify? How we find out the upper control limit? How we find how we know the central line and the lower control limit? In all these control charts, it hinges on two things. One is average, another one is standard deviation, that is the dispersion and the average. What is average? It talks about the accuracy. Standard deviation, it talks about the dispersion, or it talks about the precision. It is accurate but not precise. What does it mean? Precision means the variation will be least. Accuracy means exactly on the mean value itself. Okay. So that is why the control chart, it gives us both the things. One is the accurate or is it precise. So those precision things, how do we measure is dispersion, and we are going to fix the limits for that. Because in one of my classes, I might have explained about the bullseye, because that is what they use in case of the shooters will be using like this. The same thing here. Instead of round circles here, what we are going to put here, because this is the bullseye center, instead of that one, what we will do is central line will fix it, and the upper control limit, this means instead of the circular way, they will be in the straight line shown by the dots. It has to be within this one, it should not cross. That is what the points they are going to get is, if it is exactly here, maximum point will be scored, and if it is in this circle, compared to this one it is less, and again outer circle and other things, it will go on, the marks will go on decreasing, and if it goes this thing, he is not eligible at all. Likewise, here it identifies it should be able to hover around this central line. But in any case, it should not cross these limits. That is all about, in the nutshell, about all these control charts. And if it is going to be on only one side, this side only he is hitting, that means there is something wrong. Likewise, it is only on this side, or it is only on this side. It says the center has been shifted. Here also he should have aimed at here, but it is hitting here. That means he has to slightly move, because slightly move on the other side, maybe because of the wind or whatever it is, some assignable reasons will be there. Similarly, for the control chart, these are going to be some of the assignable reasons. Already we have discussed about it. What I intend to do here is, in general, I am talking about. So the upper control limit in general will be any chart upper control limit of any chart is equal to average plus 3 times the standard deviation. Central line is average value. Lower control limit, average minus 3 times the standard deviation. And I have also explained why we are going to take the 3. This is the 3 sigma limit. 3 times, it should be on the either way of the average value. That is what it says. This is the average value. This is on the right side of the average value. Maximum we can go about. This is what it means. And this is the lower control limit, means it can go up to the left side, or here on the chart it can be shown like this. This is all about it. Okay. Here we know C chart that the count, number of counts, and if the area of opportunity it remains fixed, then we are going to use C chart, and if the area of opportunity it goes on varying, we are going to use U chart. That is all the difference. It is just like the difference between NP chart and P chart. P chart corresponds to U chart and C chart corresponds to NP chart. That is the thing. Okay. Here, and one more thing we need to observe here is the average value and the standard deviation, or here this is the variance. The square of the standard deviation is the variance, or square root of variance is equal to standard deviation. So here we can observe that if average value and the variance both are same, similarly here it is average value C bar and the variance is also C bar, then it will be following the Poisson distribution. But if they are not same, since we are taking the mean values, these things we are plotting, considering, then it has to follow the normal distribution. Hence here you can see that U chart, it follows normal distribution, because these are both are not equal. Here the average value is U bar, whereas the variance is U bar by N. Okay. That needs, it is to be understood. Why? Because certain questions might be asked regarding the calculation of these things. Okay. Let me take some examples. Maybe C chart first, or U chart first, or sometimes P chart or NP chart, whichever it is. Just like that. Maybe because of the paucity of the time, I might be concentrating on some of the things. Okay. Okay, take down this example. A textile manufacturer initiates the use of C chart to monitor the number of imperfections found in a bale of cloth. Full point. The bale is of same length, width and fiber composition. Full point. A total of 191 191 imperfections were found in the last 25 bales inspected. 191 imperfections and 25 number of bales inspected. The four highest and the lowest counts were as follows. Highest count and the lowest. Twenty-two, 19, 14, and 12. Lowest count. Four, 5, 5. What he asks us to find out? Calculate the 3 sigma control limit. B part, is the process in control? C part, if not, what aimed value of CI and control limits would you suggest for the future period? Okay, my dear students, from the question, by analyzing the question itself, we can learn so many things. Because it contains many of the answers. Here he says, whether the process is in control or not, that itself will give a clue, because if the process is in control, he says second, and third, if not, what aimed value? That itself suggests to us that the process may not be under control. So actually that verification can do it. That is how it needs to be analyzed. We know that whether we are moving in the right direction in approaching the problem or not, it tells us. Okay? This is what is to be understood. And again, here also if you look at it, the variation is 12 to 22 here. And again we know what is the average variation. Average value we know. Average value is given over here. So that itself, by analyzing this itself, it will tell us that it may not be under control. And what is to be done if it is not under control. Okay, so this gives us a clue. So we know that first he says we have to find out the 3 sigma control limit. That means the C bar plus or minus 3 under root C bar, this one is to be found out. Okay, that is one will become upper control limit and under will become lower control limit. In any case, we need to find out C bar. And one more question at the same time, we need to ask ourselves, why he has said, why he has given information about the bill. Namely, he says, Because bale of cloth, or even sometimes they say it is bolt of cloth, B-O-L-T, bolt of cloth or bale of cloth, it means the same. What he says, each bale is of same length, width and fiber composition. Why he has given this additional information? Because the area of opportunity, what he is searching, it is fixed. It will not vary from one bale to another bale. So one bale is of, say, some 100-meter length, another bale is of 50-meter length. None we cannot. And if their width also it differs, then we cannot use the C chart. But we could have used in that case U chart. So there also it gives the number of defects also. Same thing, in number of imperfections in U chart also. But the area of opportunity, it varies. If it varies, then we have to use U chart. If the area of opportunity remains fixed, then we need to use this C chart. So that is how the distinction can be made. Okay, now let us find out what is the on an average, how many imperfections are there per bale. Okay, totally we know that there are 191 imperfections and 20 out of 25 number of bales. So average value C bar is total number of imperfections, that is 191, divided by 25, because these are the number of bales inspected. So we are interested in finding out per bale how much on an average we can expect. Okay, that is 191 divided by 25. So approximately 8, or it will work out to be 7.64. So on an average, we are going to expect 7.64 imperfections per bale. Okay, but our question now is, how much variation is allowed? Definitely he has given some 4 these things. The variation is there. And this variation, that is what at the outset we made it clear, the variation is inevitable. But how much variation one can tolerate? That is the crux. So it says we can tolerate up to 3 sigma limit. So what is that 3 sigma limit? We are going to find out. That is the thing we need to understand. Hello. Now 1 minute, class meeting. So how much variation? Whether we can allow up to 22 or 19 or 14 or 12. What is that? Okay, that is what 3 sigma limit it tells us. So that is what we say, that naturally it can vary up to that because of some chance causes. If there are some assignable causes, then it will be beyond that. That is all the crux. Okay. So now that is why we are going to find out this one. Upper control, that means what? Average value 7.64. Don't start wondering, how come one can get 7.64 imperfections? You can understand whether it is 7 or 8. Okay, fine, no. Okay, wait for the time being. Don't make the corrections over here. Maybe at upper control and the lower control we can have the integer values. Okay, generally it will be stated like this, but practically it is impossible to find out like that. Okay, okay. Let us see that the upper control limit in this case shall be what? UCL bar 7.64 plus. He says 3 sigma control limits. He is specific about it. If he says 2 sigma control limits, then plus 2 into its standard deviation, that is square root of C bar. Now he says 3 sigma control limits, so that is 3 into square root of 7.64. Okay, central line, we know it is 7.64. Lower control limit is 7.64 minus 3 under root 7.64. So, square root of 7.64 is going to be how much? Okay, it is something around 2.5 or something like that. So, it might be closer to 3 into that one. If we find out that value, it works out to be, total value works out to be so 8.29, this value works out to be 8.29. So lower control limit, here it will become negative because 3 into square root of 7.64 is 8.29, so it will become negative, so hence it is going to be 0. And here if you work out these things, it is going to be some 15.65. So upper control limit is 15.65, lower control limit is 0. That is what it says. 15.65, we don't find, see here you can see, the maximum upper high count he has given not in fractions. Okay, now actually 4 values are there, their lowest is 4, highest is this thing, because these should have fallen. These two, how we are going to interpret this one? These values should have been fallen between the limits 15.65 or you can say 15 and 0. 0 and 15. We will just compare. 0 and 15, this fourth value S, it is 12. 0 and between 0 and 15, third value S. Second value, it is not there, it is out of control. First value, it is out of control. That means, if we are, because what he has said, you just try to understand. He wants to initiate, the cloth manufacturer, he wants to initiate. That is why he has inspected to begin with. He has inspected 25 bales of cloth. And the results he has got like this. Okay, only these things he has given out separately. Otherwise, he would have given all the 25 values. Then we would have calculated those things, found out 191 imperfections like that. Instead of that, to make these things in a reduced way, he has given only these 4, they behave like this. Okay, that is how the things have been found out. And he wants to initiate in the sense, whatever the control limits we have found out here, these are called as the trial control limits. They will be called as the trial control limits till all the points, whatever we have considered, to find out the upper control limit, lower control limit, or say the central line or the average value. These things, they will be within the control limits. If they are beyond that one, then whatever exceeds, those things are to be removed. Again, fresh values need to be calculated, and again they need to be tested. What this one? Now what we will do? Now what has happened? We have established the trial control limits. So, but these two have fallen outside the control limits. So we will remove these values. Instead of 25 values, we are going to consider only 23 weights. Because here it requires homogenization, means to establish the other fresh control limits, it needs to be revised. Earlier control limits were these things, now they are to be revised. So revision, how it is done? Total value we know, now earlier it was 191. 191 minus 22 minus 19. That means the revised C bar value is 191 minus 19 minus 22 divided by 25 minus 2. These two bells have been removed. So they revised the value, it works out to be 6.52. Earlier it was 7.64. Now average value is 6.52. Again, what is going to happen to the upper and lower control limit? They are also will be correspondingly reduced. Again, revised upper control limit. If I put it here, the revised upper control limit for C chart is 6.52 plus 3 sigma 6.52, and central line, this is 6.52. Lower control limit, it is 6.52 plus 3 under root 6.52. So I think this one, it is going to exceed this. Okay? Let us see. So upper control limit, it works out to be totally 14.8. This works out to be 14.8. So that means this value is something around 7, so it is greater than this one, hence it is to be 0. And the central line is 6.52. Got this one now? What is the maximum number of imperfections allowed in any of the bells? It says you allow up to 14, not 14.8 means don't approximate it to 15, no. 14. Okay? The 14 value, 14, that means here if you again compare, because these things we had removed. So 14 and 12, yes, they are falling within the control limits. Hence, the revised standard control limits are these things. So in future, what is to be done? After some time, you collect the bale and find out count the number of imperfections. If it falls within 14, then you leave the process as it is. But if it goes beyond that, then process is to be stopped. Investigations are to be made. This is how it works. Is it understood? If so, then let us go for the next value. So I'll make this one very simple. Okay? I make this one very simple. Take down this one. A sheet metal manufacturer records the number of defects found on each sheet of metal produced. From the inspection, it has been found that the average number of defects per sheet is 9. So all the values he has given. C bar he has given it as 9. Determine the control limits for the C chart. He has given C chart. Otherwise, the appropriate chart also you could have done it for C chart only, because there you would have made the assumptions that the sheets, each sheet will be of same length and width. Next one, with these control limits, what is the probability that the process is out of control when it is really not? My dear students, in fact, I wanted to drive out this particular point. That is, with these control limits, what is the probability that the process is out of control when it is really not? Okay? Because he should have made certain changes here. Because he says when these control limits, what is the probability that the process is out of control when it is really not? Okay, that means he should have said, by using these control limits, what is the possibility of making? Which type of error now? Actually, the process is in control. But based on our observations or based on the sample, we conclude that the process is out of control. Based on the sample, but really it is not out of control. It is natural. Okay? So, what is that probability of mistake? Committing that mistake, that is called as type 1 error. Okay, let us see how it is to be found out. Now we need to decide which probability distribution we are going to use here. We are going to use the probability distribution as Poisson's distribution, not normal distribution. Since we are using, since it follows this C chart, it follows the Poisson distribution, we are going to use the Poisson's table, not normal table. Okay. So let us find out what is the upper control limit and the lower control limit. So it becomes very easy because he has given C bar is equal to 9. So upper control limit, it works out to be how much? 9 plus 3 square root of 9. So this is equal to how much? It works out to be 18. I don't understand this one. Okay, this is what is going to happen. So upper control limit is 18 and lower control limit is 0. Okay, we need to find out the area because up to 18, suppose if it were calculated as 18.2 or 18.8 also, I would have considered 18 defects only. Okay, when I want to refer this table, that is what I had explained in the previous class. What I will do, C bar is how much? It is 9. So I will go to the table 9. So it varies for 9. What is going to happen? The number of defects you can find out, it varies from 0 to around 20. It is possible. Okay? 20 defects we can find out with average number of 9. Now we can allow even up to this 20. That is what I believe. But now we are allowing only up to 18. So under the 18th column, if I look at it, this one, it works out, it says that it is 0.998. point, if I look at the area, it gives 0.998. How did I find out this 0.998? I first looked under the column C prime 9. Under that one I go now horizontally till, because 18 is there, number of under 18, that column I will see that it says that it is 0.998. Okay. Up to 18 this is allowed. Beyond that, if it consists of more than 18 imperfections, then it is, yes, it is, we conclude that it is out of control. But really, it will have the average value hovering around 9 only. But we reject the hypothesis that its average value is not 9, it is something else, more than 9. That is what it means, that is what we conclude. So this probability is how much? I can find out probability that we are being right. It is 0.998. We are not 100% right. What this one? 0.998. We are right. Okay. So another these things we need to find out. 1 minus 0.998 is how much? It is 0.002. 0.002. We are going to be wrong. Even though it is within that one, we say that it is not within control. What is? So 0.2% is making of that error. Then what is type 2 error? Try to understand this. Really the average is no longer, it is 9 imperfections per the seat. It is something else. But we are unable to recognize this one. What is that probability of making the mistake? Again that is, this time it is 0.998, 99.8%. So hence sometimes what we do, we will make the limits too close. This is how type 1, type 2 error is to be found out. Another way I will tell you, for this one also, it is almost similar, same. Even if it were, the answer is very simple. We need not have to calculate all these things. When you are calculating the control limits by using 3 sigma limits, probability of committing type 1 error, if it follows normal distribution, is how much? 1 minus 0.9973, 0.27%. Always. So here it is 0.2% because we have used the Poisson distribution, almost closer to that. So you need not have to calculate. If it is 3 sigma control limits, we are going to use, then always probability of committing the type 1 error is around 0.27%. Is it understood? This is what I wanted to drive at. Okay. Some more these things we will consider now. Okay, I will just read a particular problem and you try to identify which type of control limits are to be used. The number of students failing in an university exam was analyzed college-wise. The count of failures noticed in the colleges are 253. Okay. However, following are the four highest, the four highest number of failures are 37, 31, 33 and 38. Okay. 37, 31, 33 and 38. Okay. 31, 37, 33 and 38. Analyze the data through an appropriate control chart and check whether the assignable causes at colleges are responsible for high failures. Okay. Which chart is to be used? If you look at it, it is almost similar to the previous example, whatever we have solved. What this one? So it only tells us how broadly this control chart can be applied, especially C chart. Try to understand. Because it is directly the one of the measures whether the things are going on the right direction or not. Which chart usually is to be used is C chart in teaching and learning process. That is what it says. So appropriate control chart to be used here is C chart. But under certain assumption, because he has said 15 colleges. Now we are assuming that the strength of the colleges, each college is same. They are not differing much. That is one basic assumption. Otherwise, if one college has got 300 admissions, another has got 200 admissions, it becomes difficult. Try to understand this one. Okay. So here, that assumptions will make. And if we find out, that means here he has given what is the average value we need to find out. Average value, it is what a total number of this thing he has given as 253. Somewhere I have mentioned here, that is 253. Total number of failures, (253). Number of colleges, 15. So number of failures per college, 253 divided by 15. So this works out to be 253 divided by 15. It works out to be 16.86. On an average, 16.83 failures or 16 failures are there. Okay. Now he has given for this one highest and lowest one. Instead of that one, we'll say for 4 maximum number of failures. It is given number of failures for the top 4. Other things are lesser than this. That is what we say. Okay. If we look at others are lesser than that. So those things are 31, 37, 33 and 38. Some colleges they have got these many failures. So what I need to do, average I have found out to be 16.83. Now, upper control limit and lower control limits are to be found out. That means the under square root of this one is 16.83 is square root of 16. That works out to be around 4. Okay? That means approximately I am telling you, not precisely. So upper control limit, it is going to be 16.83 plus 3 under root 16.83. So this works out to be approximately 16 if I consider 4, 3 into 4, 12, 12 into 12 plus 16, around 28 we are going to get. Upper control limit is 28. And lower control limit, it is working out to be something around 4. Okay? So up till that one, it is allowed. That means only upper count is given. That means these 4 are more than this expected value of 28. So definitely there is a assignable reason for this. So only it stops at that, because he has not asked us to find out what are the revised control limits. Okay? If we want to find out the revised control limits, then what is to be done? Out of this 253, these things are to be, because almost 50% of this, you deduct that one and try to find out. Is it understood? Okay. So another problem will take, which will tell us the applications of this C chart. One more thing. The following data refers to the number of missing rivets on an aircraft body noticed during preventive maintenance schedule. Compute the control limits for suitable control chart. Plot the data and offer your comments. What value of C would you recommend for the future period? That again, the missing rivets, these are the defects, not defective. And the area of opportunity here, it is the wings. The area of the wing is fixed, or the fuselage, the entire aircraft is of same type. Okay. Hope you understood about this one. However, I need to discuss some more points, that is probability control limits and U chart. I have not taken up any problem on U chart. So in tomorrow's class, I am going to talk about that one, and I will try to wind up in tomorrow's class about the control charts for attributes. Okay. Thank you.